Have you ever imagined what it's like to fly straight into the shadow of the moon, chasing darkness at 460 miles per hour? Because NASA's doing exactly that, and honestly, it's blowing my mind. Picture this. Two pilots in a modified Cold War-era jet, climbing to 50,000 feet off Iceland's coast, racing against a lunar shadow moving faster than a bullet. This isn't just a mission, it's a high-speed dance with cosmic forces. But why go to such extremes? Let's unpack this. Personally, I think the real genius here is how they're turning a fleeting natural phenomenon into a lab in the sky. See, ground telescopes get blocked by clouds. Space telescopes can't beam back terabytes of data instantly. So NASA's solution? Strap cameras to a plane and fly into the eclipse's path. It's like bringing the lab to the experiment instead of waiting for the universe to come to you. That 3-minute window they gain by flying? That's gold for studying the sun's corona, its mysterious million-degree atmosphere. But wait, why is the corona hotter than the sun's surface? That's the kind of question that keeps astrophysicists up at night. And nanoflares, those tiny, explosive bursts of energy, might be the key. What many people don't realize is that these nanoflares aren't small in impact. Each one unleashes energy equivalent to thousands of atomic bombs. Yeah, that's the scale we're dealing with here. Now, let's talk about the tech. The WB-57 aircraft? It's a relic from the 1950s repurposed as a modern science platform. That juxtaposition fascinates me. The same airframe that once carried nuclear payloads is now capturing light from the sun's outer atmosphere. And those cameras snapping dozens of images per second? They're not just taking pretty pictures. They're mapping magnetic explosions in wavelengths our eyes can't see. It's like photographing ghosts in the sun's atmosphere. But here's the kicker. This isn't even the first time humans have done this. In 1923, the U.S. Navy tried chasing eclipses with biplanes. In the 70s, Concorde prototypes flew at Mach 2 over the Sahara. What this really suggests is that our obsession with eclipses isn't new. We've just kept upgrading our tools while the core mission stays the same. Touch the untouchable. But let's zoom out. Why does any of this matter beyond the cool factor? Space weather, that's why. Every solar flare and coronal mass ejection isn't just a light show. It's a potential threat to satellites, power grids, even astronauts. In my opinion, understanding nanoflares could be the difference between a solar storm knocking out global communications or seeing it coming days in advance. This isn't abstract science. It's planetary defense. And yet, there's this poetic duality here. Caspi's quote about feeling very special, but very small hit me harder than I expected. Think about it. How many humans have stood in an eclipse's shadow? A tiny fraction of the population. But now, by chasing that shadow in a jet, scientists are literally bridging human ingenuity and cosmic insignificance. If you take a step back, this mission isn't just about the sun. It's about our relationship with the universe. We're sending machines to touch the stars, but still rely on ancient celestial mechanics, a moon passing in front of the sun, to unlock secrets. The next time you hear about an eclipse, don't just think of it as a viral photo op, think of it as a portal to understanding the forces that shape our existence. And maybe, just maybe, we'll figure out how to protect our fragile tech-filled world from the very star that gives us life. What do you think? Does chasing cosmic shadows feel like humanity's most poetic scientific pursuit, or are we just staring into the dark hoping to find answers? Let me know in the comments.